So how do we graph a logarithmic function? Here we have an equation of a function y equals log base b of x. And in this video we're going to talk about how we can graph this kind of function. Now before we get into graphing, let's make sure we understand what a logarithmic function is. The inverse of an exponential function, here we have an exponential function, f of x equals b to the x. Well, the inverse of that is called a logarithmic function. And a logarithmic function is written like this, the logarithm of x base b. Or sometimes we don't have the parentheses there. So it's real important that we can convert. So let's make sure we can convert. Here we have an exponential form of an equation, and we've got b to the y equals x, and that's equivalent to saying y equals log base b of x. And it's really useful to go back and forth. So let's get specific here. Let's say we have 2 to the 4th power, and we know that that is equal to 16. Well, that's equivalent to saying the log base b, notice the base, base 2. Notice the base is the same here and here. So base means the same thing. Base is that number on the bottom of the power. Okay, and so we got log base 2 of 16. Okay, so the log base 2 of 16, this is just asking what is the power that we can put on 2 to get 16. And so if we scratch our head a little bit and say, what can we raise 2 to get 16? Well, we know, as we just saw, that that is 4. So if the log base 2 of 16 is 4, then 2 to the 4th is 16, and vice versa. So these are saying the same thing. So the key is that when we're finding a logarithm, the log is the power. The log is that exponent. That's what we're looking for. So let's try a few. Here we have a log base 2 of 8 equals something. We want to find out what that is. So the question is, 2 to what power equals 8? Well, if we think about that a little bit, we realize that x is 3. So sometimes it's useful to take this log equation and rewrite it as an exponential equation. Here we have log base 2 of 1/8. Oh boy. So we have 2, that's the base. So 2 to some power is equal to 1/8. Well, to get this fraction, we're going to need a negative power. So this needs to be a negative number to give us this fraction. And so we realize that x is negative 3. 2 to the negative 3rd power is 1/8. Okay? Likewise, we can say, all right, log base 5 of 25, well, that's just saying 2 to some power is equal to 25. What is that power? Well, I'm sorry, let's clear that up. We're saying not 2, but 5. Okay, the base here is 5. So a base of 5 to some power is 25, and x would have to be 2. Here we have a base of 3. So 3 to some power is 1/9. Well, again, we see the fraction. So we got the 1 on top, so that means x is going to have to be negative. So we have x is negative 2. Well, now let's put this all together and see how we get a graph out of these functions. So graphing logarithmic functions, we're going to do what we just did many times over. So here we have y is the log base 2 of x. So if x is 16, well, that's the problem that we saw a few moments ago, and we'll do a little scratch work down here. We have log base 2 of 16. And so if we put 16 in for x, we get this thing right here. And so we're just saying this, 2 to some power equals 16. If we want to rewrite it, we can. So this just means 2 to the y power is 16. So we think about that, and y, it has to be 4. We saw that a few minutes ago. Okay? All right. Now, what if x is 8? Well, plug in 8, we get y equals log base 2 of 8. So this is the base. Let's put this under the y power. So 2 to the y power equals 8. And we think about that for a moment and we get 3. Y is 3. If x is 2, we say 2 to what power gives us 4? Okay, if x is 4, that is. So 2 to what power gives us 4? The power is 2. 2 to what power gives us 2? Well, that's the first power. 2 to what power gives us 1? So if x is 1, we want to find out what's the power, and that is 0. Now we got a half. So what if we plug in a half for x? Well, now we're saying y equals log base 2 of 1 half. And so that's just saying 2 to the y power equals 1 half. All right, well, what is this power? Because it's a fraction, it has to be negative. And this is 2 to the first, so this is going to be 2 to the negative first. So we have negative 1. And what power gives us 1/4? That's negative 2. What power gives us negative 8? That's negative 3. So here we've got our points. Let's go ahead and graph these now. Let's say we have a scale. This is 19 out here. This is 10 up here, going by ones. And so we said this, when x is 16, y is 4. So we can find that. 16, 4, right up here. X is 8, y is 3. And we can find that guy. I've got a few marks here to help us out. And so when x is 8, y is 3. That's going to be right over here. X is 4, y is 2. Right about there. My pen will get that. When x is 2, y is 1. When x is 1, y is 0. When x is 1 half, we're going down to negative 1. X is 1/4 down to negative 2. When x is 1/3, negative 3, we're right down here. And these are going to keep getting closer and closer to the y-axis. They'll never touch it, so the y-axis is an asymptote. So our graph looks something like this. And again, the y-axis is an asymptote, so this gets closer but never touches. And this is our logarithmic curve. You can kind of see if we flip this around, if we reflect it actually across the line y equals x, then we would get this curve over here. So if we took this 45-degree line right here, and if we flipped over the curve that we just drew, we flipped this one reflected across this line, then we would get our exponential curve, y equals 2 to the x. So here we have y equals 2 to the x. This is the log base 2 of x, and they're mirror images of each other there. All right. So let's try one more here, one more basic one. Let's look at the log base 3 of x. So again, if x is 9, we put 9 in for x. We're asking what is the power on 3 that it takes to get 9? Well, the power that we need to put on 3 to get 9 is 2. Now let's put 3 in, the log base 3 of 3. If x is 3, we're asking what is the power that we put on 3 to get 3? And the power is 1. Now, what is the power we put on the base 3 to get 1? And the power is 0. The power we put on 3 to get 1/3 is going to be negative 1 now. And the power to get 1/9 is negative 2. Now you might be asking, where do these come from? Why do we pick these random looking numbers here? They're not in order. Well, if we take a moment and we think about y equals 3 to the x, which is the inverse there. We have y equals 3 to the x. Well, there we get, if we do an xy table, let's try to fix this up here. Okay. If we get an XY table for this, y equals 3 to the x. When x is 2, 3 to the second is 9. And when x is 1, 3 to the first is 3. When x is 0, 3 to the 0 is 1. When x is negative 1, 3 to the negative 1 is 1/3. When x is negative 2, we get 3 to the negative 2 is 1/9. So we're just taking this table here and we're flipping these around because the logarithm is the inverse. So these are nice and neat, and these are the powers that we get. All right. So plotting those points, we get 9, 2, 3, 1, 1, 0, 1/3 negative 1 down here, 1/9 negative 1, and again it's going to be an asymptote. They're going to get closer and closer to the y-axis there. So the graph looks something like this. All right, and so here's our graph. The 1/3, it's going to be a little closer to the x-axis. The 1/2 would be up here. I'm sorry, the third power, third base, and the base 2 would be up here. And as the base increases, it's going to get closer and closer to the x-axis. And one last thing, let's look at some transformations, some different versions of these graphs. And some transformations. So we're going to take our log base 2 graph, which we just saw, and you can rewind and take a look at that. We're going to take those and we're just going to move them a little bit. If we find the log and then we add 2, well, that's going to take all those points and it's going to bump them up 2. So with our scale on it here, let's put some dots real quickly where y equals log base 2 of x is, and we can think of it backwards. 2 to the 0 power is 1. If we go up 1, we say 2 to the first power is 2. So we're going to put a point right over here. Now we're going to go 2 to the second power is 4. So we're going to have a point right over here. 2 to the third power, we're going to go up 3 and over to 8. 2 to the fourth power, we're going to go up 4. 2 to the fourth power is 16. And then we're going to have a half, a fourth, so on and so forth. So now let's translate those. This plus 2 is just going to bump them all up 2. So everybody's going to go up 2. And we're going to end up looking like this. This one's going to go up 2 there, up 2, up 2, like this. And then we're going our half, so on and so forth. So there's our curve there. Okay. If we subtract 3 on the inside, well, like other functions we've seen, this is going to move it right or left. Subtracting is going to move it right, adding is going to move it left. So that's going to move it right 3 because it's subtracting. So let's take our red points and go right 3. And the whole curve will shift that way. Okay, and let me go ahead and draw in an asymptote here. So the asymptote was the y-axis, the vertical asymptote, but now that's going to shift. So let's put this little yellow line here. That's going to shift right 3. And now that's going to help us with our points because we're going to get closer and closer to that one instead of the axis there. And it's a good habit there to draw in that asymptote. Okay. Let's try that again. A little tricky to go through those points sometimes, especially with the stylus. All right, so there's that. And last but not least, if we take this negative 2 log base 2 of x, well, the negative is going to take all the red points and make them negative. It's going to flip them upside down. It'll take the negative ones and make them positive. And then it's going to stretch them twice as far. So, for example, we'll take this one here that was over at 16 up 4. It's going to flip it down here to negative 4, and it's going to drop it down twice as far. So we'll have the point negative 16, and we'll be down at 8 down here. Okay, so let's graph that. Oh, I'm sorry, wrong point. We're looking at the red points which got covered up. There's this red point here. That's 16. Going to go down to negative 8. There it is. Okay. All right, that puts us at negative 8. And this red point here, which was our original one, is at 8, 3. And so we're going to go down to negative 6 there. So negative 6 at 8. And this point up here is going to go down to negative 4. And this 1 is going to go down to negative 2. The y value here is 0, so it stays the same. Okay, and usually we'd be at a half 1, but it's going to be at a half 2 up there. And so these points will go on up like that. And there we have, it's going to be an asymptote of the y-axis there. And let's try that one more time. Something like that. So the red curve there is going to be, red curve is our negative 2 log base 2. The green curve here was the x minus 3, which has moved right 3. And the blue curve has moved up 2 with that plus 2. And that's how we graph these logarithmic functions. So give it a try and take your time and you'll get it.